Doesn't work. All right. Good afternoon. I hope everyone is doing well today. But we get to work. Put your pencils down, pick up your colored pens. Let's see how you did. So, there was really one question and then an extension of that question. So, the answer to the question. Let's see how we did. I got students 16, 7, 9, 8, and 17. Student number 16, what do you say?
128.
Okay, student number 7, what do you say? Student number 9, what do you say? Student number 8, what do you say? Student number 17, what do you say? So I got 5 students in the room who all think that it is 128. Of course, it's 128 feet. But yes, 128. Now the extension. I asked you to try and write an expression that could be used. No matter what length we had for the bridge, we could always use the same expression to figure out how much material would be needed for the top and the bottom of the bridge. So what expression did you come up with? I got students 13, 6, 19, 1, and 2. Student number 13, what do you say?
X divided by 3 times 2 plus x.
Okay. Student number 6, what do you say?
1/3 x times 5.
Okay. It's a little different. Student number 19, what do you say? Okay. 2/3 x? I didn't know if you were done. Student number 1, what do you say?
1/3 times x parentheses times 5.
Okay. And student number 2, what do you say?
5/3 x.
Okay, wow, we got, I think 2 people said the same thing and everyone else said something different. So, there's good news for a lot of you. A lot of you have something that's same meaning as this, but the simplest way to write it would be 5/3 x. However, if you in any combination somehow indicated that you had to divide by 3 and then somehow multiply by 5, that would work. And some of you put 2/3 x plus x, and that's the same thing, but you failed to realize that 2/3 x plus x can be written as 5/3 x. That's a much simpler way of looking at it. So if you're not sure if yours is right, go ahead and let me know, and I will tell you whether or not it's the same thing. John, yours is the same thing. You already know that. Nathaniel?
I got the question wrong, but I read it wrong. Well, when I thought they said they calculate the amount of material needed for the top and bottom of the bridge, I was thinking that you had to make 2 separate equations.
Okay, 2 separate expressions. So one expression for the top and one expression for the bottom.
That's why.
Well, but again, let's not think of it as right and wrong. So what were your expressions?
I couldn't find another one, but I made 2/3 x for the top.
Well, but the bottom's already done. If this is x, how much material do we need for the bottom? There's no 30 there anymore. So I'm sorry you're getting a little confused. Forget about the 30. There's no 30 there. I am now saying that this is x. How much material do we need for the bottom? X. And you figured out that the top is going to be 2/3 of that, because if you cut that into 3 equal pieces, and these are equal to these, then there's 2 out of the 3, that's 2/3 x. So you did everything that I asked you to do, you just need to be able to put it all together. Okay, good. Any comments, questions? For my students who got 5/3 x, super duper kudos to you for realizing that there was a simpler way to write what you had figured out and going that extra little bit. That's great. Any comments, questions on today's warm-up? Any observations or concerns? Good. Now, what was the correct answer to yesterday's question? It's already out on your desk because you knew we were going to grade that. I never told you what the right answer was. What was the correct answer to yesterday's question? I had told you that someone had said it, but we seemed a little bit divided. Caleb? What do you say, Kadir?
182.
Yeah, the correct answer yesterday was 182. Because some of you made a false assumption. Some of you assumed that these were equilateral triangles. However, they are not. They are isosceles triangles. And if you put the height right there, and you do the division in this case, in today's warm-up, you will see that this is 5, because if we divide the 30 by 3, we get 10 from here to here. Then we're doing the perpendicular bisector, that makes that 5. This is 12 because it's the same distance as here. How do we get that this is 13? Where does that come from? Kamoy? Yeah, Pythagorean theorem, or Sharik?
Pythagorean triple.
It's a Pythagorean triple, 5, 12, 13. So yes, Pythagorean theorem will of course get that for you, but you would have been able to figure it out in a nanosecond if you know your Pythagorean triples. And so then you realize that each of these segments on the bottom and the top are 10, and each of these diagonal segments are 13 each. And so you've got 50 on the top and bottom, and 78 on all the diagonals, and you get 128. So what were the diagonal pieces? What were the lengths of the diagonal pieces in yesterday's question? See, the reason we're so hesitant is because some of you are not doing your job properly. Some of you are immediately picking up your calculator and punching in a bunch of things. But you failed to realize that there was value into actually writing something down. And I just proved it. I had students who were sitting in this room who thought today's question was the same as yesterday's question, and all they did was write down what they wrote down yesterday and did absolutely nothing. How could you make that mistake if you had written down yesterday's question and you wrote down today's? You would have clearly seen that they were different. So you need to make a little bit of effort to write something down, whether it be a quick little sketch or some numbers that you're manipulating, something at all. So still, answer my question. What were the measurements of the diagonals yesterday, Alexandra? They came out to 17, and each of the segments on the bottom and the top were 16 each. Very good. Any comments, questions, or concerns? Any thoughts, any observations? Good. We're doing well. So today, as you already know, we're going to be entering lesson 7.4, and we're going to be working with special right triangles. So we've established a lot of ideas about triangles in general, and recently we explored right triangles, and last lesson we explored a lot of things that come out of when you draw an altitude in a right triangle. Today we're going to explore 2 special cases of right triangles. So, our objective today is to understand and apply theorems about right triangles. Okay? There's no new vocabulary. All the terminology that you're going to hear today, you've already heard before. So, let's first start out with the cheat sheet. And the 2 theorems and the 2 ideas kind of all wrapped together. There are 2 right triangles that are very unique. One of them is an isosceles triangle, and we refer to it as a 45-45-90. And what it means is if you have an isosceles triangle and it's a right triangle, then you must have a 45-degree angle here and here. And what will happen is that the side lengths will always be in the same relationship. Since it's isosceles, this and this will always be the same, and the hypotenuse will always be radical 2 times the length of this side. Because of this relationship, we are able to figure out the legs, or we're able to figure out the hypotenuse, depending on what information we have. So one of your jobs is going to remember this relationship that's outlined right here. That the sides are x, the legs are x and x, and the hypotenuse is x radical 2. And that's a 45, 45, 90 degree triangle. The second case is called the 30, 60, 90. If you have a right triangle that has a 30 degree angle, it will also have a 60 degree angle. And the side lengths will be in the relationship as shown. The smallest leg will always be x. The longer leg will be x radical 3, or radical 3 times the length of the shorter leg. And the hypotenuse will always be twice the length of the short leg. So, when you think of 45, 45, 90, you're immediately thinking of x, x, and x radical 2. When you hear 30, 60, 90, you are immediately thinking of x, x radical 3, 2x. It's going to have to be kind of instantaneous. And we can use these relationships to solve lots of different problems. Any questions so far on terminology or what you're seeing so far? Good, so let's start exploring. So, part A, we're given a diagram. You just need to sketch your diagrams for most of today. And we have some information, and we're asked to find the length of the hypotenuse. For a right triangle, the hypotenuse is the opposite side from the right angle. So we're talking about that length right there. So, we have lots of different tools in our toolbox. We're adding one today. If you can establish that a triangle is a 45, 45, 90, then you can use the relationships that come out of that. So the first thing we have to do, as with everything we've done this year, is establish whether that's true or not. So the question is, we have 90 and we have 45. The question is that a 45 degree angle also? So it's a yes or no question, but you need to support it with fact, evidence, reasons. So, is that third angle a 45 degree angle? Give me a thumbs up if you think it is. Okay, good. Keep your thumb up if you can tell me the reason why. Good. Matthew, what's the reason why? Beautifully said. The triangle sum theorem, of course. So we now know that that is a 45 degree angle. Now we can use the relationship that comes out of that. And the relationship is this, that the legs are equal to each other, and they're both called x. But in this case, we have the measurement, so we now know that that's going to be 8. So we figured out that length. And now the length of the hypotenuse. The hypotenuse will always be radical 2 times the length of a leg. 8 radical 2. Unless we are talking about a real world scenario where we need the actual distance of something to do something with it, leaving it in radical, simplest radical form is the best way to leave it. So there's not a lot of thought going on in this particular example. It's just I'm trying to establish with you the basics. What's going on with a 45, 45, 90 degree triangle? Any questions so far? Okay? No questions? All right, so let's take a look at part B. Go ahead and do a quick sketch. So we want to be able to use this new tool that we have, 45, 45, 90-degree triangle theorem. But we have to first establish whether or not this is a 45, 45, 90. Is it? Give me a thumbs up if you think it is. Got a few people who think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, keep your thumb up if you can tell me the reason why it is. Okay, Dayanara, why?
It's like that base of a isosceles triangle.
Good. Good. I love the way you said that. You didn't know the exact name, but you were able to use keywords. And it's just called the base angles theorem. And that was great. Yeah, the base angles theorem says that if this is congruent to this, then this angle must be congruent. This angle must be congruent to this one. And if they're congruent to each other, and this is already 90 degrees, then we have 90 degrees left, and we have to cut it in half. Which means this is a 45-degree angle, and this is a 45-degree angle. So now we've established what it is, now we can use the relationship. These two sides are called x. So this is x. This side, the hypotenuse, is going to be x radical 2. In other words, it's going to be this times radical 2. So take this value and plug it in right here. And here's what we end up with. 3 radical 2 times radical 2. What do we get when we simplify that? Give me a thumbs up when you got it written down. A couple people figured it out. Good. John, what is it?
6.
X told, do you agree?
Yeah.
Yeah, it comes out to 6. When you multiply a radical times a radical, basically you get the number inside the radical. So that's a 2 times 3. And so the hypotenuse is 6. Does anyone have any questions about that? Any concerns? Any observations or theories? Okay, so now So, we're given a verbal explanation, a written explanation of a scenario. I personally work better with visuals, so I would immediately just make a sketch. And it's not going to be perfect. Doesn't really matter. It's a sketch. And so I'm going to call this the right angle here, even though it's not perfect. And this is a length of 6, the hypotenuse. And we're being asked to find the length of the leg. And we're already told that it's a 45, 45, 90-degree triangle. We don't have to establish that. We're told it. So we have to find this distance. Got a minute? See if you can figure it out. We need the leg of the triangle.
Wait, you multiply these? I had it. Okay, these two.
Anyone figure it out? Okay. Well, whether you're right or wrong doesn't matter. We'll start with Nathaniel, John, Eric, Kadir. What do you got? Okay.
Approximately 4 times 2.
Okay.
I want the method that we use.
Nope. I just want to know what you got.
4.2.
Okay. Okay. So we got 2 people agree on one answer. You agree on another. Anyone have a different answer that they came up with? Doesn't matter if you figured it out because we're still learning. So there's a couple of different ways to think about this because this is going in reverse of what we did here. This was easy. I mean, this was ridiculously easy. If you have the leg, all you have to do is take the leg and multiply it by radical 2. That's it. We have the leg, multiply it by radical 2. That's it. But now we're going in reverse. So now we have the hypotenuse, we have to get the leg. So if to get from the leg to hypotenuse you multiply by radical 2, what do you think you have to do to go in reverse? Stephen? Yeah. So if you take the hypotenuse and divide by radical 2, you'll go in reverse. However, we do not leave things like that. You learned something last year in which you were taught how to get rid of a radical in the denominator. We never leave a radical in the denominator. And Nathaniel's going to remind us how to do it. How do you do it? No, that's sort of not really what we do, but it's called something else and we do something else. Sharik?
We multiply both the numerator and denominator by radical 2.
Yeah. It's called rationalizing the denominator. You multiply the top and the bottom by whatever radical you're trying to get rid of. And so you get on top 6 radical 2. And on the bottom you get 2. And 6 divided by 2 is 3. And so that's why, although Nathaniel, I'm guessing, did it slightly differently, and why Kadir, I'm not sure if he did it exactly this way, you end up with 3 radical 2. Now, my other 2 students who proposed approximately 4.2, sure, that's equivalent, it's close, but again, you rounded, and so your answer is less precise than this answer. So we want things in radical form. So you have to be able to do this rationalizing the denominator process, which is not super complicated in the scheme of things that you've learned. It's not super hard, but it's something you have to remember how to do. Nathaniel?
My team did a different process of getting the side answer.
Go ahead.
Since we did part of B, there was the same hypotenuse length, which is 6, and so we just looked at the leg.
Oh, I didn't even see that, and I didn't even do that on purpose. So you just knew that it was 3 radical 2. Okay, good. You used prior knowledge. Good? Is that what you did? Okay. Good. Well, I guess for next year I'll have to make sure I change that. That's a little too easy. But hopefully you understand how you actually get it if you didn't know what the answer was going to be. Okay? Any comments or questions on any of this? Okay. So let's see how you do with these two. And I intentionally gave different style questions, asking slightly different things. It's supposed to stretch. Stretch your mind. Allow it to take what you've learned and apply it in a different scenario. You got 2 questions, you got 3 minutes. Okay, let's see how we did. On part A, you're going to tell me the value of x and the value of y. Tell me both. Student number 21, 13, and 6. Student number 21, what'd you get?
X equals 14 and y equals 7.
Okay, and student number 13.
Same.
Say it again.
X equals 14, y equals 14 times square root.
Okay, and student number 6, what do you say?
Y equals 19.8 and x equals 9.9 times radical 2.
Okay, so we do have some disagreement. X is 14, y is 14 radical 2. And we'll get back to how in a moment. Part B, what did you get? I got student 8, 1, and 4. Student number 8, what do you say?
Oh. X equals 7, y.
Okay, student number 1, what do you say?
X equals 7, y.
Student number 4, what do you say?
X equals 7, y equals 7.
X equals 7, y equals 7. That wasn't very
difficult.
So we did get thrown off a little bit by part A, though. Could someone tell us why x is 14? Why is x 14? Zimar?
Isosceles triangle and the hypotenuse has the same value as the other triangle.
Mm-hmm.
So it's the same thing as the legs on the other triangle.
Okay, I see what you're saying. Anyone have a different way of saying that x must be 14? Alexandra? Okay, so that's kind of what she's saying. So you say they're congruent triangles. How do you know? Okay. Angle side angle. Okay, come on.
I did like 14 radical 2 over radical 2 and multiply both top and bottom of radical 2. I got 28 over 2 and
Okay. Good. So we got a lot of different explanations. What if I did this? What would you say about x now? See some people got a little grin on their face. Why is x 14 now? Sharik?
Because it's a square.
Because it's a square.
Square.
It's a square. It's a perfect square. So of course x is 14, but all your explanations were wonderful. But yeah, x is 14 because once you pay attention, this side is congruent to this one. That's a right angle. This has to be a right angle. Once you establish these two are right angles and you figure out the rest, this has to be a square. And so that has to be 14, and from there everything falls into place. Kadir, do you know where you went wrong?
Technically, I got it right. Radical 2 actually equals, like, well, it equals 14 if you like round it.
You said x equaled 9.9 or something like that.
Yeah, it's like radical 2.
You're fired. Absolutely fired. Okay. So any comments or questions about checkpoint number 1? Okay, so we've added a new tool to our toolbox. We now know that if we have a special triangle called a 45, 45, 90, that we can use the relationship of the side lengths to help us find solutions to problems. Let's add one more tool to our toolbox, the 30, 60, 90 triangle. So, the 30, 60, 90 triangle theorem says that if you have a right triangle in which the other two angles are 30 and 60 degrees, that the short leg will be x, the long leg will be x radical 3, and the hypotenuse will be 2x. So we're asked to find, in this case, find x and y, and we have the longer leg. So now we're kind of forced to go a little backwards, kind of like we did in the last example. So if going from the short leg to the long leg, we multiply by radical 3, what do you think we have to do going from the long leg to the shorter leg? Let me say it again, because I know some of you are struggling with the focus. If we establish the relationship, this is a 30, 60, 90, to go from the short leg to the long leg, we multiply by radical 3. What do you think we need to do if we have to go in reverse? Zimara? We have to divide by radical 3. Because look, if we want x from this, we divide it by radical 3, and that will cancel out. And we're left with x. So if we understand that, then we can go ahead and take this measurement and divide it by radical 3. So take the 9, divide by radical 3, and that's this measurement. But we are not allowed to leave it like that. So you take 30 seconds and rationalize the denominator, and I'm going to go ahead and do it here as well. Give me a thumbs up if you got it. Oh, we got a bunch of people who got it already. Good. Kalasia, what is it? Very good. 3 radical 3. So we went backwards, sort of, going from here to here. Now we can go from here to here. This is x, this is 2x. So whatever this value is, multiply it by 2, and you get the hypotenuse. So now, not so difficult. What will y be? What will y be? Just got a couple people who can do that mental math. Go ahead, John.
6 radical.
Yeah, it's just 6 radical 3. 3 radical 3 times 2 is just 6 radical 3. And so we have found the values of x and y, the missing lengths of this right triangle. Anyone have any concerns or questions about that? Any observations or patterns that you've noticed? Nothing? Okay. So part B, I do not need you to copy the text of the question. I want you to read the question, and I want you to put something down to represent it. You don't need all the text, but you need something. So as I indicated earlier, I'm a visual person, so I'm going to sketch a picture. To me, that makes the most sense. I was trying to hint at that by telling you didn't need to write the text. So I'm going to sketch. I'm not going to pick up my ruler. I'm just going to sketch because it doesn't need to be perfect. So we have an equilateral triangle with side lengths of 6 centimeters. So we've got 6, 6, and 6. And we're asked, what is the height? So now we're asked for this. Give me a thumbs up if you think you can do it. Okay. So you take a minute. You see if you can figure it out. This is not a checkpoint. It's just give it a shot. See what you can figure out using the tools that you have available to you in your toolbox. able to figure it out? Give me a thumbs up if you already figured it out. Wow, a lot of you figured it out. Stephanie, what did you get?
3 radical
Dianara, what did you get?
3 radical 3.
Kamoy? Oh, you guys all figured it out. How'd you do that? Stephanie, how'd you do it? Pythagorean theorem. Okay. Well, Pythagorean theorem works with right triangles. We have an equilateral triangle. So how'd you do that?
Oh, well, the line in the middle, so I divided 6 by 2, and then I got the
Okay, so you use this, and since this is the height of an equilateral triangle, that is also a perpendicular bisector, which then divides this into 2 equal segments. And so this segment here is 3. Okay, so I'll buy that. So let's take this out of the way, and you say, excuse me, you say that this is 3. Okay? And then you do the Pythagorean theorem. A squared plus b squared equals c squared. Good for you. Dianara, how'd you do it?
It's an equilateral triangle, so all the angles are 60.
That's right. So this is a 60. Hold on, let me put that in. This is a 60. And that's a 60. And that was a 60. Go ahead.
And the top angle was divided in half, so it's
Okay, so we divide this in half, so this is now a 30. And that's now a 30. Okay, keep going.
and the height is like a perpendicular bisector, so that angle is 90.
That's right. So this is now a 90-degree angle right here. And so I'm going to help you out a little bit visually right here. So what do we now have, Dianara? We now have a 30, 60, 90 triangle. And so you can quickly see that this is x because it's the shortest side. This is 2x because it's the hypotenuse. And this is going to be x radical 3. In this case, x is 3, so we get 3 radical 3. Excellent, and I love the explanation. And I love Stephanie's explanation as well. You'll notice that both methods earned the same results. And so Stephanie wasn't confident or didn't click for her that it might be a 30, 60, 90 triangle because of the fact that they're all 60 degrees. But she had another tool at her disposal that will work, and that was great that she figured that out. Dianara did recognize right away that once you cut it in half, it's a 30, 60, 90 triangle, and was able to use this new tool in her toolbox. Great job. Anyone have yet another way that they did it? Okay, give me a thumbs up if you did the Pythagorean theorem way. Very good. Bunch of you, excellent. Give me a thumbs up if you recognize that it was a 30, 60, 90 and did it that way. A few of you. Good. Well, considering today's lesson is partially about 30, 60, 90, do you see why that's significant now? Very good. Any concerns or questions? Okay. Do you have checkpoint number 2? Remember that I'm asking you to stretch a little bit. And you've got 2 questions. And there's a little typo. This is a 60-degree angle, 45-degree angle. I am going to clarify a couple of things. So you have this truck, and using this arm, it can push up or come down. And when it pushes up, the body, this is calling this the body, I would call it the dump truck part of the truck, gets pushed up further. And so it's 14 foot from right here to here. This is 14 feet long. How high is it up in the air if it's tilted at a 45-degree angle, and how high up in the air is it if it's tilted at a 60-degree angle? Because this can go up and down. It can go past 45. It can go past 60. I don't think it can go all the way up to 90, but it can go pretty far up. Any questions about what I'm asking you to do? All right, see what you can do. You got 4 minutes. Go.
Let me tell you a picture. No, please stop. This is that figure. What? Can you do it?
No, because I just lived about
Saying like when it tilts up. So this is the leg, this is the little body part right there, and this is the body part. It's like that, and that's the leg. No, I'm not gonna find the tire, the body part is this. It's saying that when it goes up like this, this is what the coefficient is. I don't know if it's different. That's right. Alex, okay, and then this is X, 2, so 14 is X. I can do it. The body is actually kind of like spinning. Is there any action?
Doesn't matter what it's at right now, I'm telling you that I wanna know how high it's going.
Okay.
I'm assuming.
Just forget about the picture. I have a triangle. Oh, this is 14 right here. This is 14.
All right. So let's see how we did with this moderate level question. So for part A, how high will the body of the truck be when it's at a 45-degree angle? I got students 14, 8, and 3. Student number 14, what do you say? Okay. Student number 8, what do you say? Okay. Student number 3.
7 minus 2.
So everybody is correct. Oh, I'm sorry, you said 12.12? You said the wrong answer. So it comes out to approximately 9.9, and 7 radical 2 is the same thing as approximately 9.9. In this case, since it was a real-world scenario and we were talking about a distance that mattered, I put approximately 9.9. But again, I would accept 7 radical 2 as well. Part B. Part B, what did you get? I got student 15, 1, and 18. Student number 15, what'd you put?
I didn't solve it.
We'll wait.
So we're gonna take the rest of the class now.
Oh, really?
Maybe I don't know how to solve it.
Did you get part A?
I got it wrong.
So when I say did you get part A, I guess I meant did you get part A correct. Okay, so I appreciate your struggles. That's no big deal. Student number 1, what'd you get? And student number 18, what'd you get? Okay, so we have some disagreement. What about student number 13? What do you say?
12.1.
And student number 20, what do you say? Okay, well, comes out to approximately 12.1. So, this is absolutely challenging. There's no two ways about it. But you had to figure out what was actually going on. And so what was going on was that we establish this triangle right like this. And we're told that this is 14 here. I did clarify that for you. And I'm asking you, what would this distance be right there if this was a 45-degree angle? If that's a 45-degree angle and this is a height, must be a 90-degree angle, then that must be a 45-degree angle. And so we have established the 45-45-90 relationship. And this is x, and this is x radical 2. And so to solve that, you have to go in reverse. You have to take the 14 and divide by radical 2. And so if you do 14 divided by radical 2, you get 7 radical 2, or you get approximately 9.9. But now let me back up. Now take the exact same picture, but instead of saying that's going to be 45, now let's pretend that that's a 60-degree angle. This is still 90 degrees, but now this is 30. This is still 14. Now we need the relationship that comes out of the 30, 60, 90 triangle theorem, which says that the short leg, and my drawing is not good because it's misleading. This looks like it's bigger than this one, but it's supposed to be the opposite. And so this is actually the short leg, and this is the long leg, x radical 3, and this is 2x. This is 2x, which means x must be half of this. X must be 7. And this distance is x radical 3. So we get 7 radical 3, and when we simplify that, we get 12.1 or 12.12 approximately. So it was all about drawing the picture. The whole thing was drawing the picture. I'm not saying it was easy, it wasn't. Could you?
So like, what's the radical like 9.9?
What do you mean?
Like in radical
It was 7 radical 2.
and I had 9.9.
The last question.
Yeah?
So can I get my job back?
The last checkpoint?
Where he had like that crazy.
No. This is 7 radical 2. This distance is not.
No, A.
Oh, in part A? No. It says 14 radical 2.
Yeah. And yeah, but he said 9.9 is radical.
It's 7 radical 2. 14 radical 2 is not going to be 9.9. Yeah, I'm sorry, you're still fired. Pretty confident that you won't be getting your job back either. Okay, so definitely wasn't easy. Let's see how you do with the team challenge.
It's a canyon.
Checkpoint number 3, you're on your own. Team challenge, work as a team, try and figure it out. You got 5 minutes.
We're just gonna find that missing short.
Oh, the question is I don't know. Yeah. Question is
Well, actually, it's not that much. I mean, 4,850. You could, that's the list. Yeah, so all you have to do is multiply by 4. See, now you know how to finish the answer. And now you know.
I know you guys work at
What do you have trouble with?
Not in trouble.
You're not? Wait, are you doing the radical simplifying? But you don't need to simplify the radical because you're finding the actual distance.
This is incorrect. He gives an incorrect question.
It's easy.
Oh, yeah, you can do that.
Yeah, pretty much. Whenever you're ready, X start. You're not ready.
Yeah. Sorry. Oh, guys, I saw it.
So what you had?
Approximately 600.3. Or 5600.2, 56 alone.
Yes, sir.
When I told you, I started
I didn't hear you guys say anything to me.
when I tried to do it, it so randomly.
Yeah.
Oh, yeah, yeah. And then after the slide, you can get right behind
All right. Give me a thumbs up if you and your team were able to come up with an answer, or just you as an individual. Okay, I've got two.
Did you get an answer?
I'm asking if you got an answer.
Oh, I got it.
Okay, so I got team here, that team there. So half my team's got an answer.
Wrong answer.
Okay. Well, so as I've said to you many times, knowing the answer doesn't matter, it's how. So I'm going to reveal the answer so my teams who have answers can go ahead and check theirs. If you are not done and you see the answer, it doesn't matter. You still have to be able to do it. So the correct answer is what? Valid?
Approximately 5,600.3.
What do you say?
Approximately 5,600.2.
Okay, so pretty darn close. So I'd say if you're rounding it properly, you should have gotten 5,600.3, but if you said 5,600.2, I don't know if I'll fire you today, but I'm going to start looking at you closely. I might have to fire you tomorrow.
Oh, I got 0.4. It's like 5,600.4.
Okay, well I guess it kind of depends on if you round it along the way, but it comes pretty close to 5,600.3. So I'm not talking yet about how. I've revealed the answer. My teams that did not finish, you still have to figure out how we arrived at this answer. If you got the right answer, you should feel triumphant and you should feel proud that you were able to work through it. My students who didn't get it yet, it doesn't mean you did something wrong. It's not a matter of speed right now. It's a matter of knowing what to do. But I will help you along. Could someone tell us, without the answer, tell us what we can use to represent this side of this triangle that we established? What should I label that segment? Valerie? This is going to be X. And I know that this is already 4850, but without the number, what would we label that segment? Stephen? That's X radical 3 because we're using the idea of a 30, 60, 90. And so then the hypotenuse distance will be what? Eric?
5,600.
No, I want the model.
Oh, X, 2X.
2x, very good. So now that we have that established, you can use the information here to work around, but also keep in mind that I'm not just asking you for one of the segments, I'm asking you for the distance from here to there. Okay? So again, I'm not telling you exactly how to do it. You know the answer, you have a starting point. John?
You also have to prove that it's 40, 90, 45, 60, 90.
45, 60, 90?
30.
30.
30, that's right. And so we already see the 60 and the 90, so you have to be able to demonstrate that, and we can establish that by using, very good. Draw a line across your paper. Your homework is on page 455. You're doing numbers 7 through 18, 23 to 26. 26 requires some extra effort, 31. And 34A, you're only doing part A, and that's worth 6 points because there's actually 6 different things you have to find. And I'm asking you to mark each one of them separately on purpose. The more points I give you, the more possible points, the better off you are. There are online interactive quizzes for 7.1, 7.2, 7.3, 7.4. I would encourage you to do some of them in preparation for tomorrow's quiz. And tomorrow's quiz will be exactly that, 7.1 to 7.4.